Hello everyone. In this video, we'll be solving problem 904, fruits into baskets. The problem statement is, we are given an array of fruits where each element in the array represents the type of fruit. We need to collect the maximum fruits we can using two baskets while moving from left to right. Each basket can hold only one type of fruit with unlimited quantities. Let's look at example number 1. We have a total of two types of fruits, 1 and 2, which are distributed amongst three entries. With two baskets that can hold only one fruit each, we can collect all three fruits. The first basket can hold all of the fruit of type 1, while the second basket can hold all of the fruits of type 2. As we were able to collect the fruits from 3 rows, the output is 3. While in example number 2, we have a total of 4 rows with 3 unique fruit types, 0, 1 and 2. Considering the requirement that we need to pick at least one fruit from each tree starting from the first point all the way to the right, maximum number of fruits we can collect with this example is going to be 3, where we'll start collecting the fruits from index 1 all the way to index 3. Between those two indexes, there are only 2 unique fruits available which will fit in the baskets. I hope you were able to understand the problem statement at a high level. Let's walk through a couple of more examples which will help us unblock how we can solve this problem efficiently. Let's look at this example. The problem statement is asking us to collect fruits from each tree as we move towards the right, which means we cannot select any random rows or trees in the given array to make our output. All of the value needs to be contiguous or next to each other. For instance, we cannot put 0 in one basket and 2 in another basket. It has to be next to each other. So if we want to put 0 in one basket, the other basket should have 1 in it. The same applies with other combinations. For this example, we could have a combination of 0, 1 in two baskets, 1, 2 or 2, 3. Between these three combinations, we need to look for the maximum length of the subarray and return that as our output. As we were going through the examples, this appears to be a sliding window related problem, where we have two pointers left and right, and we are adjusting the values of them based on a certain criteria. The criteria here is to make sure that we have two baskets with unique or a single type of fruit in them. If the basket condition is satisfied, we'll try to expand the window by incrementing the right pointer, or else shorten the window by incrementing the left pointer to make sure that the condition is met. As discussed, the criteria here for the window is to make sure we have exactly two types of fruits in the basket. When we try to expand the window and we encounter a third type, we should remove the fruit that left pointer is pointing and increment it by 1. I hope you are able to understand how sliding window will be helpful here. Let's do a dry run with this example to get a better idea. So we have two pointers left and right which will determine the range of the window. This column will record the total number of unique fruits we have between the left and right pointers, and the length will determine the range of this window. And this max variable will record the maximum length of the window that we iterated so far. Let's start with left pointing at 0 and right pointing at 1. Between these two values, we have a total of 2 unique fruits available. The length is 2. As 2 is maximum right now, I'll save 2 into this variable. As the basket criteria is still valid, let's increment the right pointer to expand the window. The next value is 2. Now I have 3 unique fruits available, which breaks the criteria. With this combination, we cannot proceed further, so we need to increment our left pointer until the basket is valid. Incrementing left by 1 and right will stay as is. So my new range is this part from 1 to 2. Between these two, the unique number of fruits are 2. The length is 2, not greater than the current maximum, so nothing needs to be replaced. Continuing with incrementing my right pointer to 3, the left stays as is. Between these two values, we still have 2 unique fruits in the sub array, so we can continue. The length over here is 3, which is greater than the current maximum, so I'll replace it. Let's try to expand our window to see if we can fit in one more fruit. Now we are looking at this window. In this window, there are a total of 3 unique fruits which do not meet the criteria, so we cannot use it as is. This time we'll increment our left pointer to shorten the window. So the new value is 2. The right pointer is pointing at 4. Between these two values, the total number of unique fruits are 2, which matches the criteria. but the range or the size is 3, which is not greater than the current maximum. So we'll not replace any values here. Similarly, we'll try all possible combinations to increment our left and right pointer to see if we can get the maximum length of the subarray or the window. With this solution, the time complexity is O of n, where n is the size of the input array. This is because we are running a loop to iterate through all of the elements in the given array only once, while the space complexity is going to be O of 1, as we are only using a couple of variables to use as the left and the right pointer for the window, and the basket of length 2 that will record the maximum number of fruits that we collected in the window. I hope you are able to understand the explanation. Let me show you how we can implement this approach using C#. In this C# implementation, I am using a dictionary of type integer and integer, where the key will be the type of the basket and value will be the starting index. After that, I'm initializing a left pointer and the maximum fruits. Post that, I'm starting a for loop to iterate through all of the elements, and the pointer will be the right pointer. Inside the for loop, I'm saving the right pointer into the basket where key is the type of the fruit that the right pointer is pointing. If the size of the basket is greater than 2, it means we need to remove the first fruit type that was added to the basket. To identify the first element that was added, I'm running a for loop across all of the elements in the basket's array and calculating the minimum index. And once I have that available, I'm calculating its corresponding fruit type and removing it from the basket, and later incrementing my left pointer by 1 so that I can shift my entire window. The next step is where I'm calculating the size of the sliding window using the right and the left pointer, and then comparing it with the max fruits which were calculated over time, and the higher value will be saved back into the max fruits variable. Once the for loop is complete, I'm returning the max fruit as our output. This code, when submitted on LeetCode, beats nearly 92% of the submissions in terms of runtime and nearly 47% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.